Welcome to NASA Edge.
An inside and outside look at all things NASA.
We are very excited today to bring you exclusive footage of the total solar eclipse from Antarctica, which is cool all in and of itself. What do you think, Franklin?
I think it's totally awesome. You know, I've seen a couple of eclipses in my time, but to have witnessed one from Antarctica would have been definitely a bucket list event.
That's right, the continent, bucket list, and eclipse, which is great. But I tell you what, we're very happy to bring you this footage, and it's really in thanks to the J.M. Pasachoff Antarctic Eclipse Expedition. Christian Lockwood and his team, Theo Boris, were very kind to provide this footage, and we're super excited to share it with you later in the program. But Franklin, you brought up something. This is like a bucket list kind of thing. I mean, it's not very often that we have the opportunity to see an eclipse, and to see it now in this context is great. What do you think?
I think it's going to be absolutely amazing. You know, besides that, we'll have some subject matter experts on our show today from NASA headquarters and the Goddard Space Flight Center to kind of enlighten you on the phenomena of eclipses and why NASA studies them.
Tell you, it's a really good point. And you know what? One thing that we always stress when it comes to eclipses is safe viewing. Anyone, whenever you have the opportunity to see an eclipse, whether it's in the Antarctic or whether it's in the United States or anywhere else, you always want to do so safely. And that requires, for the most part, using some solar eclipse glasses. So make sure you always have a pair on hand. Even though we know when those eclipses are going to happen, usually you want to be prepared.
Yeah, Blair, both you and I know about wearing glasses. I've been wearing them since I was in the 3rd grade, so I don't want to damage my eyes any more than they already are. I do have a pair of solar viewing glasses here that I can wear for any future eclipse. So make sure when you are watching an eclipse, you make sure you get a pair of these.
That's great, Franklin, and it's good that you're prepared. But I tell you what, let's get on with the show so we can get to that footage. And joining us now is our very first guest, Kelly Couric from NASA headquarters, who's a program scientist and heliophysicist. Kelly, thanks for being on the show.
Thanks for having me.
One of the first questions I have right off the bat is about the eclipse. Eclipses are spectacular astronomical phenomenon. How does NASA study eclipses?
So NASA studies eclipses because they are these amazing phenomena and great opportunities to do some science. There are ways to study them from the ground by taking pictures as they occur naturally, but also we use artificial eclipses in things such as the LASCO coronagraph in order to observe space weather. And in astrophysics, we use eclipses that happen of exoplanets in front of their host stars to find exoplanets.
NASA has a bunch of missions designed specifically to study the sun. Can you tell us about some of these solar-centric missions?
Definitely. We have the heliospheric observatory fleet. So it's no one spacecraft, but 20 different missions with 27 total spacecrafts that go from the closest to the sun, Parker Solar Probe, to the furthest from the sun, which is the Voyagers 1 and 2, and kind of everything in between. Near the Earth, we have a concentration of them studying things such as aurora, as well as the incoming solar wind and space weather.
Do many of these missions take into account how eclipses are studied on Earth so they can be used in parallel with some of the ground-based observations?
Definitely. There are coordinations among the entire fleet, and that's really what makes it so strong, is that, you know, any one observation is great, but putting them together gets us a lot more information. So for instance, campaigns can be put together of asking folks to take specific data on a satellite as well as take specific data on the ground. And again, currently there is a LASCO coronagraph that actually makes a man-made eclipse by an occulter disk, putting a little, basically your thumb in front of the sun in order to see everything around it. So we also make our own eclipses when we don't have one available.
It kind of seems like cheating to make them, but not really.
Cheating in the best way.
Right. Cheating for good, that's important. Now I'm wondering, we also have solar max and solar minimum in the solar cycle. How important is it in the development of these missions to take into account the solar cycle of the sun?
So this solar cycle that we're talking about is this 11-year cycle where the sun goes from not active, so very few coronal mass ejections or flares, these great big huge explosions, to be very quiet. So you go from not active to not active. And we do plan our missions around these, and we can study different phenomena during that time. During solar minimum, there are less flares, so less studying of energetic particles, coronal mass ejections, all of these phenomena. We get a good picture of what the star looks in a quiet configuration or supposedly a more simple configuration.
With Artemis on the horizon and more humans going out into space, back to the moon and onto Mars, these solar missions are very important. How do these solar missions work with their partners to make sure that our astronauts are safe when they fly in space?
Definitely. It is all about partnership to understand space weather. So when we're talking about exploring as human and robotic exploration as well, those coronal mass ejections, those flares, that energetic particles really can affect those. So the Science Mission Directorate Heliophysics Division is charged with really focusing on understanding the science. What happens? Why does this happen? And we partner with even other government agencies such as NOAA, who will do the predictions to actually tell what's going to happen basically on Earth space weather and tell us when we need to do things like maybe avoid EVAs or other things like that. So that's a close partnership and tie-in working with other folks as well as the exploration, as well as even things like planetary division. We're working with the Mars rover and the rad detector there to really understand space weather at Mars as we go towards that exploring there.
I'm still longing for the day when space weather reports include my favorite topic, magnetosference. It's my own coined word related to space weather, and hopefully as NASA progresses, maybe it will catch on. What do you think?
I think so, yeah, definitely.
Awesome. More and more buy-in. I love it. Kelly, thanks so much. Enjoy the eclipse, and I hopefully will be talking more and more in the future about NASA solar missions.
Thank you.
Always great to hear more about NASA missions, especially as it relates to the sun and the eclipse. And Franklin, I don't know if you noticed or not, but I got some buy-in on magnetosference, and I want to share with you what we've got from the wardrobe department at NASA Edge, this cool Eclipse Wear magnetosference t-shirt. What do you think?
I think it's absolutely great. You've been working with magnetosference. You've coined the phrase quite a few years ago, and I think it is about time that it makes its way into the mainstream.
Yeah, and it's probably the only way I'm going to get into the scientific community in any real, tangible way. But I got to tell you, Franklin, it is really exciting. When we think looking forward, actually, at these NASA missions, it's really profound what NASA's doing, because they're not just looking at an eclipse or even just at the sun. They're looking at the whole solar system and how the sun affects it in a lot of different ways, and it's so helpful from a scientific standpoint.
And you know that this eclipse is not our first rodeo when it comes to dealing with heliophysics and sun missions. A couple years ago, we did Parker Solar Probe, and right now, Parker Solar Probe is breaking a speed record of traveling over 360,000 miles per hour around the sun. So those out there who haven't seen our Parker Solar Probe show, go to our YouTube channel, pull up the Parker Solar Probe show, and see what NASA is doing with its exploration of the sun.
Yeah, Franklin, I'd like to see Sammy Hagar write a song about that speed, because that's an incredible record. Now, one thing I've noticed today, a lot of twofers here. I mean, the eclipse is amazing, but it's in Antarctica. And then with Parker Solar Probe breaking a speed record, but it's also the spacecraft flying closest to the sun. We've never seen any NASA spacecraft go that close, and that is amazing. Because like I said, getting some incredible science as a result.
And that's a good thing. Exploration and research is definitely the name of the game, which leads us to our next guest, Dr. Michael Kirk, who is a research scientist in the Solar Physics Lab at the Goddard Space Flight Center. How you doing today, Michael?
Oh, I'm doing pretty well. It's a gloriously sunny day, which is my favorite kind of day.
First of all, as we get into eclipses, can you tell us what an eclipse is and how many different types of eclipses are there?
Yeah, so eclipses just mean something is passing in front of something else in astronomy speak, so to speak. And what we see here on Earth is there are two different kinds of eclipses. There's the lunar eclipse, which is where the shadow of the Earth is covering the moon. And we just had one a few weeks ago. The moon turned sort of a ruddy red color as it passed into the shadow of the Earth. And then a solar eclipse is where the shadow of the moon is shining on the Earth itself. And so the sun gets covered up by the moon itself. So those are the two major types of eclipses, the lunar eclipse and the solar eclipse.
Now, the eclipse that's happening in the Antarctic is what type of an eclipse?
That one is a solar eclipse, and it's a specific kind of solar eclipse, and then it's a total solar eclipse. What that means is that all of the sun is blocked out by the shadow of the moon, all of it. And so what you can see with a total solar eclipse is you can see the other parts of the sun that we normally need special equipment to view, the solar corona.
Now, there is another type of solar eclipse. Can you tell us about that?
Right. Yeah, so there are two other types, but one is only a half type. So let's start with the other type first. So the other type is an annular eclipse. This is another type of total solar eclipse, as in the entire moon shadow passes in front of the sun, but it doesn't quite cover everything. And so you get this annulus of light around the outside, this thin ring all the way around the outside of the sun. And one thing to mention with those annular eclipses is that you have to use special equipment to view them with your eye. You can't look at them directly. With a total solar eclipse, when you're in totality, you can take off your glasses and see the beautiful solar corona. With any other type of eclipse, you've got to use special protection. So then another type of eclipse you'll often hear about is a partial solar eclipse. Partial solar eclipse is where you just see the shadow of the moon take sort of a bite out of the sun. It's sort of a Pac-Man kind of a thing, where you just get, a bite taken out of the sun and that's it. And those are interesting, but they're not quite as magical as the annular eclipse and the total eclipse. So that's why I say partial eclipse is only like a half type, because it's like a near miss. It's like a swing and a foul ball kind of a thing. It's not exactly like you're getting all the glory that you'd want to in a total solar eclipse.
Since the sun doesn't go down, how can you actually view this eclipse? In the Antarctic, the sun is going to be on the horizon, will it not?
Yeah, exactly. So this is the summertime for the Antarctic, which means if you're south of the Antarctic Circle, then the sun is never going to set. It's just going to stay above the horizon 24 hours a day. That's weird and cool and kind of crazy itself. But what that means for the eclipse is that you're going to get to see the entire progression of the eclipse, from when the moon shadow first touches the outer edge, and then all the way as it progresses through to totality, and then marches back out on the other side again. So you get to see that whole process from start to finish. However, the totality of the eclipse only lasts for about 2 minutes, just under 2 minutes. So in the grand scheme of a 24-hour day, 2 minutes is really not that much time at all. So it's not that much of a viewing experience different than what you saw in Carbondale or what you'll see coming up in the future. But the actual shadow of the moon will be covering the sun for about 2 minutes, and it'll be nice at a nice viewing angle. So you just don't have to crane your neck so much. You don't have to get that crick in your neck like you did before. You can just look up easily. And that's why so many people are going down there, is because it's this unique viewing experience in the Antarctic to see a total solar eclipse.
Dr. Michael Kirk, thanks for being on with us today, and hopefully we'll talk to you again in the future during our next solar eclipse.
I can't wait. So mark your calendars now. 2023 is an annular eclipse in the US. 2024 is a total solar eclipse in the US. So I will be talking to you more about all those things as we get closer.
Sounds great. Can't wait.
Thanks.
So Blair, it looks like our eclipse itinerary is set. We have a couple of eclipses coming up that we should be covering through NASA Edge.
Franklin, I really hope so. It is very exciting. There's a lot of eclipses on the horizon, maybe pun intended. Not really pun, but a horizon, etc. Pretty funny. But listen, seriously, we are very excited about eclipses. We covered the one in 2017. We have one also going across the United States in 24. So whether we cover it or not, there are lots of opportunities for people in the States to see them in person. So we again need to remind folks, make sure, you have a few years now, but make sure you have good solar eclipse glasses to enjoy the eclipses when they arrive.
And Blair, one thing that is important to learn about eclipses is that what we're viewing and what we are researching here has a lot to do about space weather.
Yeah, that's a good point. I mean, I do try to push magnetosference because it is a space weather related word, but it really actually is a big area of interest for NASA. We do need to understand space weather. We need to understand how our planet is affected by things at the sun. So obviously NASA wants to talk about this topic and they want to learn about it. And so it makes perfect sense for our next guest to join us, Jesse Woodruff, who's also a program scientist and heliophysicist. Jesse, thanks so much for being on the show today.
Pleasure to be here.
We are really excited about the eclipse down in the Antarctic, and I know your expertise is in space weather, so I'm wondering, can you tell us the connection between space weather and eclipses? Why are eclipses important to you in terms of space weather?
So an eclipse is very interesting from the perspective of space weather because it gives us an opportunity to see things in a different way, and it gives us a chance to see the Earth and its environment react to a very different phenomenon. An eclipse basically turns the sun on and off really quickly, and the sun is the primary source of space weather. So what we see in response to an eclipse is a bunch of space weather effects that we might not normally know are coming. But because an eclipse is so predictable that we see it coming, months or years in advance, we know to be on the lookout for these things, and we can bring all of our resources to bear in watching for them. So it's a great opportunity to get more data and observations for space weather.
Obviously, it's important to understand how space weather impacts us here on Earth. But can you tell us a little bit about how space weather might impact NASA missions?
Sure. Well, space weather, of course, impacts almost every aspect of NASA's mission. On its most fundamental level, space weather is just studying the effects of the space environment on human activities and human technologies, both on Earth and in space. And of course, NASA more than anyone has human activities at the space station and soon to the moon and Mars and someday beyond, as well as numerous scientific resources in low Earth orbit, medium Earth orbit, geostationary, and beyond. So everywhere that NASA has something in space, there is a need to understand the effect of the space environment on those assets. Because if we don't properly account for those and properly prepare for them, all of the great work that NASA does in science and human exploration is possibly endangered.
And actually, some missions actually study space weather. In fact, the UVSC Pathfinder, which is launching with the Laser Communication Relay demonstration, has on board a coronagraph, which mimics an eclipse in order to study solar electric particles, or SEPs. Can you tell us why these particles are interesting to NASA and why we study them?
Sure. So one of the most important types of space weather effects that we see is the release of highly energetic radiation from the sun, these so-called SEP events. These are basically high-intensity radiation that is emitted from the sun and heads out towards Earth. When this reaches Earth, it can cause a dangerous radiation environment for humans in space, such as our astronauts, and even in some cases, that radiation can be of sufficient intensity to reach the surface of the Earth. And so in order to better prepare for and give warning for these solar energetic particle events, which can take only 7 or 8 minutes to reach the Earth, we need to have good observations of them. Because if we have astronauts in space, they need to have a chance to get somewhere safe. And as we move out beyond the protective shielding of the Earth's magnetosphere, it is going to be yet more important for people near the moon or Mars to get this forewarning because they will not have the safe shielding of our magnetospheric home.
Well, I'll tell you what, thanks so much, Jesse, for being on the show. This is very exciting information. Enjoy the eclipse, and hopefully we'll talk more in the future about space weather on NASA Edge.
Thank you very much for having me.
Tell you what, Franklin, it's been great to hear from everybody that joined the show today. We heard about NASA missions, we heard about eclipses, space weather, all of this building to this incredible event of capturing and watching the Antarctic eclipse. It's going to be awesome.
Absolutely, Blair. And whether you're viewing an eclipse in person or on your smart device or television, seeing an eclipse is an amazing phenomenon, and I can't wait to see the footage that we have.
And we do want to thank the J.M. Pasakoff Antarctic Eclipse Expedition, Christian Lockwood, Theo Boris, and the whole team for working so hard to bring this to us. Thanks to NASA TV and the folks that are bringing this to you on television, all the folks that made this happen. It's an incredible event, and you know what? It's a sign of great things to come in terms of eclipse viewing, and it starts right here with the 2021 total solar eclipse from Antarctica. Let's check it out.